All right, you guys. So today we are going to go over linear programming. So this is a little bit harder of a concept. So just kind of take your time, go through the problems step by step, and once you break it up by the 5 steps, it's not too bad. Okay. So anyway, so these linear programming problems are really to like they're used in like kind of business concepts. So you can kind of see how the first one is talking about this girl who's selling her different pinatas that she makes. Um, and anyway, so you really do these problems to see like what the maximum profit she can make based on how much she's selling her pinatas for and how much time she can actually work and how many she can sell and stuff like that. So it's kind of trying to figure out like what is my maximum profit that I can make. Okay. So anyway, so number one says pinatas are made to sell at a craft fair. It takes 2 hours to make a mini pinata and 4 hours to make a regular size pinata. The owner of the craft booth will make a profit of $14 for each mini sold and 22 for each regular size sold. If the craft booth owner has no more than 40 hours available to make pinatas and wants to have at least 16 to sell, how many of each size should be made in order to maximize her profit? Okay, so you can kind of see how this is kind of like a business idea, like, well, how many should she make to like make her most amount of money? Okay, so anyway, we are gonna have like I can't remember off the top of my head, but I think it's like 4 or 5 steps. Okay, so step one. Okay, step one. Oh, you cannot see that. Let me pull over the camera. Okay, so step one is to define your variables. Okay, and you can really use whatever variables you want. Like some people in this problem like to use like M and R for mini pinata and regular pinata. I just typically stick to X and Y just because we're going to graph these. And so I just like to stick to X and Y. So I like to first write down what my X and Y represent in the problem. Okay, so my X in the problem represents, and you kind of just think about what two things you're talking about in the problem. And kind of a trick I like to tell people is if it has this question at the end, this kind of question at the end kind of tells you what your variables represent, because the variables are representing what you don't know, right? And so it's asking how many of each size pinata should be made. So that's what we don't know, how many of each size that she should make. So that's what my X and Y are going to represent, the how many mini pinatas or the number of mini pinatas that she makes, and Y is the number of regular size pinatas. So number of mini pinatas, and Y would be, sorry, my hand's kind of in the way, number of regular sized pinatas. Okay, so that's kind of step one, just figure out what your variables are representing. And then step two, I like to go ahead and write what we call the objective function or the profit function. So I think I like to start there because they're pretty easy to pick out. Because for word problems, you're going to have to like kind of pick out the different numbers and write different equations. So I like to go ahead and pick out my profit equation first. So step two is to find and it's called the objective function. Objective function. And like I said, I like to just call it the profit function. And so what we're going to do is we're going to look in the problem and we're going to see, let me use a different color. We're going to see how much profit she's making or how much money she's making, or and sometimes we have problems that are about like quizzes and tests and stuff like that. And so for like a quiz and test problem, you would look for how many points you're getting. For the profit function, the objective function, you're just looking for like what you're getting, like what you're profiting. So for this one, it says she's going to make a profit of 14 for each mini and 22 for each regular. Okay, so my profit function would be then, okay, it's always P equals That's why, oh, you cannot see that. Let me scoot that up. Um, that's why I like to call it profit function because it's P equals. But anyway, 14 is mini. So mini, remember, we're representing with X. So we'll do 14X plus, and then 22 is regular size pinatas, which we're representing with Y. So plus 22Y. So that's kind of how you write the profit function. And we're not actually going to use the profit function or the objective function until the end of the problem. Okay, so we're just going to kind of write it and then kind of just leave it alone. We're going to leave it, we're going to use it at the end of the problem. Okay. All right, step 3 is to write your constraints. Okay. And so the constraints are like your equations. In this case, they're going to be inequalities that you're going to write based on the problem. Okay. So that's kind of like the hardest part is writing your different constraints, your different inequalities. Okay. And so I try to break it down. And what we're going to do is we're going to look at the information and kind of information given here and kind of match the units together. That's what I always like to tell my kids. You match the units. So for example, if we look at the first thing it says, the first number it says it takes 2 hours. So 2 hours. So we see how the units on that are hours. So in the equation, like in the inequality we're going to write, we can only pick things that also say hours. Like we're not going to match hours with something random like money. That doesn't make sense, right? So we have 2 hours, and then for this mini pinata, which remember is X, and then we also have 4 hours, so that has the same units, right? Hours, for a regular size, so that's Y. Okay, so hopefully you can kind of see it taking shape here. So it would be kind of start out setting up 2X plus 4Y. Okay. And then let's look to see if there's anything else that says hours. Yep, right here. It says she has no more than 40 hours available. Okay. So no more than 400, or not 400, 40 means that she can't go over 40, right? No more than. That means she doesn't have time to do 50 hours, right? She can only do 40 or under. And so the inequality sign we're going to use here is less than or equal to 40. Okay. So that's my first constraint. And so we're at least going to have 2, 3, 4. You're gonna at least have 2 constraints. Most of the time we have like 4. So anyway, that's our first constraint. Also, just kind of a side note, you're really always going to have the constraints X needs to be greater than or equal to 0, and Y needs to be greater than or equal to 0. Because we can't have negatives in these problems, right? We can't make a negative amount of pinatas. So we have to specify that X's have to be greater than 0 and Y's have to be greater than 0. Okay? So you can kind of just throw those in. All right, and then let's keep reading. I think there was one other piece of information. Yeah, so we got all these numbers, that number. So the last thing it tells us is that we want to have at least, let me use a different color again. All I have is black now, so let me use black. At least 16 pinatas to sell. Okay, that's the last thing that it tells us. And so I like to tell my kids whenever it has like one last piece of information, a lot of the times the equation that you're going to write for that is X plus Y. But the reason for that is because it's talking about all pinatas, right? It wants us to have at least 16 pinatas. It's not specifying mini pinatas or regular size pinatas. If it did, then we would only use X or Y, but it's just saying pinatas in general. So it's saying all minis plus all the regulars, so X plus Y, have to be at least 16. So at least 16 means greater than or equal to 16. Right? Like if you have to be at least 16 to get your driver's license, right? You have to be 16 or older. So at least 16 is greater than or equal to. Okay, so that was the hardest part, writing those constraints. Okay, so that's kind of like the bulk of these problems. Okay, and then from there, step 4, I'm running out of room here, but step 4 is to graph. Okay, so we are going to graph these constraints. So the first two are not in slope-intercept form, so we have to change them to slope-intercept form first. So I'm going to do it off here to the side. Oops, I'm hitting buttons on my computer. Okay, so we need to get y by itself. So first thing we got to do is subtract over that 2x. Hopefully we know how to do this at this point. So we have 4y is less than or equal to, and these can't combine, right? Those aren't like terms. So we're just going to write, and I'm going to put the x in the front. So the negative 2x in the front, and then plus 40, because 40 is positive, because I want it to look like y equals mx plus b. Okay, and then last thing, we're going to divide everything by 4, right? Because we're trying to get that y by itself, but it has that 4 in the front. So we get y is less than or equal to, and then negative 2 over 4 reduces to negative 1/2. And then 40 divided by 4 is 10. Okay, so we're going to go ahead and graph that. And you've been going over the last few days how to graph those things. So hopefully you feel good about graphing these. So we'll start at this number, this 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we'll start at 10 on the y-intercept or y-axis. That's the y-intercept. Okay, and then this is the slope right here, negative 1/2. So that means we're going to go down 1 because it's negative. So down 1, right 2, down 2, or sorry, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And I tell my kids to go all the way until you hit the other axis. I know it's kind of a pain, but you need to do that for reasons, for step 5 reasons. Okay, so you just need to do that. Okay, so that is this. Okay, so let me connect that. Okay, and then last thing is shading. And so I don't actually shade yet because I feel like if I shade 4 times, it gets really, really messy. So what I do instead, you see how this says y is less than or equal to? So less than or equal to means like lower, right? Below the line. So instead of actually shading below the line, I'm just going to make arrows below the line saying, okay, that is where I'm supposed to shade. I'm just going to wait until the end to actually shade because we're going to have a lot of functions. Okay, so that's the first function. Now we got to do the same thing for the second function. We need to graph that one. So x plus y is greater than or equal to 16. So this one's a little easier. All you have to do is subtract the x over and get negative x plus 16. Okay, so we'll start here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. So up here at 16. And then there's a negative in front, so that's really like a negative 1. So you'll go down 1 over 1, down 1 over 1, down 1 over 1. And like I said, it's a pain in the neck, but you're gonna want to keep going. And this is really important where they overlap. I'm gonna like bold that point because that's an important point. But anyway, you're going to want to go all the way until you hit the axis. That is very important. Okay, so let me draw that. Okay, and then that one says greater than or equal to. So we are going to shade up, right? Greater than. So instead of, like I said, instead of actually shading, I like to go ahead and make arrows pointed up to show kind of like where I would shade. But there's a lot of functions, so, you know. All right, and then the last part are these. X is greater than or equal to 0 and y is greater than or equal to 0. So those are just like the flat like lines. So y is greater than or equal to 0 is this flat horizontal line here, like that. And then x is greater than or equal to 0 is this flat line here, the like straight up and down line, which I know is kind of backwards. Like you'd think x is the horizontal, but it's not. It's the vertical line. And y you would think would be the vertical, but it's the horizontal. But anyway, and then those are both pointed greater than, right? So like this way. Okay, and so really the reason I did that is so that things didn't get super messy. What you're gonna look for is where all, like one area where all of the arrows are pointed. And so the only area where all of the arrows are pointed are this little area here. Okay, so that's the only part I'm gonna shade, is that little part there. Okay, So I know these problems are long. We're still not done. Okay, so we have one more step. What we're going to do, our last part we're going to do, is we're going to take these points here, these vertice points, and we are going to plug them in for our profit equation. Okay. And so when we plug them into the profit equation, that's going to show us how much profit we're going to make. And so we can see how many of each pinata she should make in order to maximize her profit. Okay, so first let's write down what these points are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2, 3, 4. So 12, 4. Okay, 12, 13, 14, 15, 16, 0. And then the last point, oh, you can't even see that. I'm writing them up here. Okay, so 12, 4, 16, 0, 17, 18, 19, 20, 0. Okay, well, obviously 16, 0 is not going to be my maximum profit if I have 20, 0, but you know. Okay, and then you're going to plug those into this profit equation here. So we'll do 14 times 12 for this one, plus 22 times 4. I'm just plugging this in for X and that in for Y. And you just put that into the calculator. So 14 times 12 plus 22 times 4. That's a profit of $256 that she would make if she sold 12. Remember, X represents mini pinatas. So if she sold 12 minis and 4 regular size, she would make $256. Okay. All right. Let's see. Let's keep going. So we'll plug in for this one 16. 2 times 0. So really that's just 14 times 16, right? 14 times 16. So that's 224. Obviously that's not the most amount of money. Okay, and then the last one would be 14 times 20 plus 22 times 0. Okay, so 14 times 20 would be 280. So we can see that the most amount of money she can make here, given these these parameters, these constraints, is going to be this, right? That's the most amount of money she's going to make. And so in the end, I'm going to write like kind of a conclusion statement over here. I'm going to say she should make 20, and remember the X was mini pinatas. So 20 mini and 0, actually she shouldn't make any regular size. That's good for her to know, right? That she would waste her time if she made the regular ones. So 0 regular sized pinatas to make max profit of $280. Okay, so that's kind of my conclusion out of all of this. Okay, so I know it's a lot, and I don't even know how many minutes it's been. It's probably been already 15 minutes. But so let's go ahead and do one more. And then there are going to be 2 on the back that are very similar to these 2 on the front. And I will, post the answer key to those so that you guys can try those 2 on your own and see, how well you did. Okay. But anyway, let's at least go over one more full problem together. Okay. So this one says a ski manufacturer makes cross-country skis and downhill skis. The manufacturer makes a profit of $85 on cross-country skis, $60 on downhill skis. The company wants to make no more than 100 skis. They must make at least 15 cross-country skis, 20 downhill, but no more than 60 downhill. So how many skis of each type should be made to maximize the profit? Okay, so this is kind of a lot of information. Let's take it a step at a time. So remember, step 1 was to define the variables. Okay, so I'm going to use X and Y again. Like I said, you can use whatever variables you want, but I like to use X and Y since we're going to graph these. Okay, so let's see. Manufacturer makes a profit of 85. I don't know why I'm rereading this. So remember, X and Y represent what you don't know. And so remember, kind of like a trick, you can look at the end question to see what you don't know, right? So this is saying how many skis of each type should be made. So we don't know how many cross-country skis and how many downhill skis. So that's our variables, the number of cross country skis. Yo, I don't even know the difference between cross country and downhill skis. Maybe you guys do. Downhill skis. I didn't even know multiple ski types existed. All right, anyway. So those are my variables, okay? Step 2, we're going to write our objective function, our profit function. Okay, so P equals, and so remember, you just look for profit, like how much they're making. So they're making $85 and $60. So 85x plus 60y. That's our profit function, which remember we don't use until the very end, right? To plug our vertice points in. Okay, step 3, we got to write our constraints. This is the hard part, right? Writing the constraints. Oh, sorry, that is really crooked. There we go. Okay, so let's kind of take it one step at a time and let's see what we are talking about here. Okay, so first thing it says is the company wants to make no more than 100 skis. So do you guys see how this is not specifying what type of ski? It's just saying skis in general. So whenever it doesn't specify the type, it's just going to be X plus Y, right? Because both types of skis together. We want it to be no more than 100. So no more than is less than or equal to 100. Okay, let's keep going. So then it says they must make at least 15 cross-country skis. So at least 15 cross-country skis. So that one, you see how, like, versus this one, it just said 100 skis, but this one says 15 cross-country skis, so it's more specific, right? So since it's more specific and it's just talking about cross-country skis, remember that's X. So we're going to say X needs to be at least 15, so that's greater than or equal to 15. Right, and oh, you can't see that. There we go. And because I have X is greater than or equal to 15, I don't need, remember up here how we needed that X is greater than or equal to 0? We don't need that this time because we know we're at least going to be greater than 15 already. So kind of takes care of that. And it says we need to make at least 20 downhill. So at least 20 downhill. Remember that's Y. So Y needs to be greater than or equal to 20. Right? And then last thing it says is no more than 60 downhill. So no more than 60 downhill means less than, right? No more than that. So, and downhill, remember, was Y. So we also have Y is less than or equal to 60. Okay, so those are all my constraints. Those ones are a little bit easier than the one above, I think, but hopefully that made sense how to write all those. Okay, after that, remember we graph those. Okay, so off to the side here. Okay, you guys can see it. X plus Y less than or equal to 100. Remember, we got to get Y by itself, so we'll subtract that. Negative X plus 100. Oh, sorry, I changed the inequality sign there. Y is less than or equal to negative X plus 100. Okay, and so we will graph that. And so you guys, since we're having to go up to 100, I'm going to count by tens. So that, you know, I'm not going off the grid. Okay. Wait, hold on. Let me count. Actually, I just counted. I'm actually going to go by fives. The reason I changed my mind is because you see how this is 15. So I don't want to count by tens because then 15 wouldn't be on like a perfect line. So I'm actually going to count by fives instead. So anyway, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 75, 80, 85, 90, 95, 100. Okay, so we start at 100, and then the slope is -1, right? That's what's in front of that x. So that's going to be down 1 over 1. And once again, we got to go all the way down. I know it is a pain, but you could see why up here it was important because we needed to know what those points were to plug in, right? So you have to go all the way down. It is a pain in the neck, but, you know, you got to do it. Go all the way down. Okay, there we go. Okay, and then we'll make the arrows. So this says y is less than or equal to, so that means below. So I'm going to make little arrows pointed down. Okay. All right. So that's the first function. And then these functions are easier. These are just straight lines, like up and down and left and right lines. So it's kind of backwards from what you would think. X is greater than or equal to 15 is a straight up and down line. Okay, so we'd go to 5, 10, 15. That'd be here. Do a straight up and down line. So I'm going to bold that point where they crossed right there because that's an important point. And then it says greater than or equal to, so that would be to the right. Right, greater numbers are to the right. Okay, and then for the y's are left and right lines. So we're going to go to where y is 20 and 60. So let's start with 20. So 5, 10, 15, 20. So it's here. Oh God, you guys, you see how bad I just drew that line? That would cross here if you know, were better at drawing than me. Okay, and that's also greater than, so that would be above. So you can kind of see the shape here where it's probably going to be shaded. All right, and then the last is y is less than or equal to 60. So 20, 25, 30, 35, 40, 45, 50, 55, 60 would be here. Wait, let me count that again. Just make sure. 5, 10, 15, 20, 40, 45, 50, 55, 60. Yeah, it's here. Okay, and that's less than or equal to, so that would be below. So you can kind of see that this little trapezoid here would be the shaded area. Okay, so after we graph everything, our last step is to take our vertice points, right? So we have a vertice point here, a vertice point here, a vertice point here, and a vertice point here. And we are going to plug those into the profit equation. Okay, so let me write down the points over here. So we have the point 1, 2, 3, 2, 3, 4, 3, 4. Sorry, we're counting by fives. So 5, 10, 15. 5, 10, 15, 20. So 15, 20. Okay. This is 15, 60. Okay. Let's see. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 80. I think that's at 80. 80, 5, 10, 15, 20, 80, 20. All right, and then this last point here, which most likely will probably be the maximum because it's kind of like the biggest numbers, but it could be this 80, 21. Those are pretty big numbers. 15, 20, 25, 30, 35, 40, 30. I think it's here, right? Yeah. 5, 10, 15, 20, 25, 30, 35, 40. It's 40. I'm losing my mind. 35, 40. Yeah. Okay, so that's 40, and then 5, 10, 15, 20. Oh, that would be up at 60. Let me recount this. I feel like I counted that wrong. 5, 10, 15, 20, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Yeah, that's 80. Okay. All right. So those are all my points. Oh, you can't even see the last one. There you go. And then we just plug all these into this profit function right there. Okay. So I'm just going to do it in the calculator because I'm running out of room to actually work. Okay. So we'll do 85 times the first X value is 15 plus 60 times 20, right? So I'm just plugging these in here for X and Y into this equation. So that's 2,475. So that's $2,475. Okay, so same function, but now I'm going to plug in 15 and 60. So that's going to be 4,875. Definitely more money. Okay, same function, but let's change this one to 20 and then the first one to 80. So that's $8,000. So steadily going up here. All right, and then the last one is 60, 40. So that's $7,000. Okay, so you can see that then this obviously would be the best, right? Because we make the most amount of money. Okay, so our conclusion statement I'm going to write here is going to be they should manufacture, I think that's how you spell that, 80. And then remember, 80 is X, which was cross-country skis. So I'm just going to write CC, skis. And 20, right? The Y value is 20, and the Y value represents downhill skis. So I'm going to put DH because I'm being lazy and I'm running out of room. They should manufacture 80 cross country and 20 downhill skis to make max profit of $8,000. Okay. So I know that this is a little bit tricky. So anyway, I want you guys to go ahead and try the 2 on the back. I would make a video on it, but you know, we are running out of time. So I will just post the answer key to these. So you guys go ahead and try these 2 yourself, check the answer key, see how you do, and hopefully you do pretty well.